In this video, we will demonstrate how to add a nozzle to a vessel. Click on number 12 in the Add Component column to add a nozzle. We add a simple name, N1, and a simple description, Inlet, to our nozzle. Now let's move to the Component Attachment tab. We attach our nozzle on one of the toruspherical ends through the Attachment Component drop-down. There are different attachment methods available. We will go with Central Nozzle on Head. Now let's move to the Design Data tab. In the Process Card's Input chapter, we can see that the nozzle already has the process card information from its primary component. You can't change the process card of the nozzle unless you change the process card of the primary component. We move to the Nozzle Data Input chapter and select Seamless Pipe Fabrication. In the type of opening, the first three options refer to classic nozzles with or without flanges. The other two options refer to openings on vessel shell, which may or may not be reinforced by studding outlets or pad-type reinforcements. Now we select a typical nozzle with flange. We move on to the Nozzle Geometry Data Input chapter. Having selected Seamless Pipe from fabrication options above, the piping library is available, where user can select pipe diameters and thickness by clicking on the arrow button. We select the XS thickness for normal size 12 inches. We also include a reinforcing pad and input its geometry data. For utilising the Nozzle Limits of Reinforcement tab correctly, please contact our support department. Typically, this option is used for adjacent nozzles. Typically, for full penetration nozzles, particular analysis is not required. That is why Exclude Analysis of Welds is pre-selected. For ASME code, however, the second option provides rigorous analysis of welds per UW16. We can also perform a WRC analysis of nozzle loads by selecting it from the Nozzle Data tab. In the Nozzle Loads tab, we select some predetermined mechanical loads from the library for NPS equals 12. We see that all the loads have been filled in automatically. Now we will add a nozzle material, SA106 Grade B. We use the Advanced tab to search for the material. We will also change the reinforcing pad material to SA516 Grade 70. Component liquid isn't really involved in nozzles, so we move on. Now we move on to the Nozzle Standard Flange tab to enter the data for the flange attachment. We select Welding Neck Flange type and DN equals 300 in the Flange Data tab. We will input some geometry data about the neck, more specifically, G0 equals 12.7. Notice that all other geometry data change automatically. Here, we can choose to perform calculation per ASME 8, DIV.1, UG44, where we check the flange rating, accounting for external piping loads. The bolt torque for standard flanges can be calculated by a simplified ASME PCC1 method. For flanges calculated rigorously, i.e. per Appendix 2, more options for calculating bolt torque are available. Now we will select a material for the flange. Here we can see all the available flange material groups. We select the first group, 1.1. We save our component by clicking Calculation Details. Now we exit the Calculation Details view. And after the vessel has run, we click on the 3D button to view our vessel in a 3D environment. Here we can see our new component attached on the bottom head. Our nozzle has been created successfully.